Problems involving volume and surface area. A cylinder of wax of a radius of 12 centimeters and a height of 21 centimeters is melted down into two candles, one in the shape of a sphere and the other in the shape of a cone, and the cone has a radius of 7 centimeters and a height of 5 centimeters. Assuming no wax is wasted in the melting, calculate the radius of the sphere to the nearest centimeter. Okay, so what we need to do is start off with the cylinder that has a radius of 12 and a height of 21, and we need to find the volume of that cylinder. So the formula for the volume of a cylinder is pi r squared h. The r represents the radius, the h represents the height. So we're going to swap the r for 12 because we were told the radius was 12 with brackets around it, and we swap the h for 21 because we were told the height was 21. 12 squared times 21 is 3024, and we're going to leave it in terms of pi for the moment. So the volume of the cylinder is 3024 pi centimeters cubed. Now we were told that the cylinder of wax was melted down into two candles, one's a sphere and one's a cone. And that means that the volume of the cylinder is equal to the volume of the sphere plus the volume of the cone. So the volume of the cylinder, which we got to be 3024 pi centimeters cubed, is equal to the volume of the sphere plus the volume of the cone. So this is very, very important to how we continue on with this question. So the volume of the cylinder is equal to the volume of the sphere plus the volume of the cone. So we're going to have the volume of the sphere plus the volume of the cone equal to 3024 pi centimeters cubed, because the volume of the cylinder is 3024 pi centimeters cubed. So we're going to fill in what we know. Well, for the volume of the sphere, we actually don't know anything about it at all. So all we do there is just write down the formula. So volume of a sphere is 4 over 3 pi r cubed. Okay, so then we have the volume of the cone, and the formula for that is a third pi r squared h. But we actually do have a bit of information about the cone, because they told us in the question that the cone had a radius of 7 and a height of 5. So in our next step, we're going to substitute 7 and 5 into the formula. But we let both of these formulas added together be equal to the volume of the cylinder. In our next step, we sub in our information about the cone. So radius of 7 and a height of 5. So we swap the r for 7 and the h for 5 in the volume of the cone. And we can also cancel out the pi's that are common to each of our terms. So we're left with 4 over 3 r cubed plus a third times 7 squared times 5, and that's equal to 3024. 4 over 3 r cubed stays as it is, and a third times 7 squared times 5 gives us 81 and 2/3, and this is equal to 3024. So now we need to solve for r. So what we're going to do is bring the 81 and 2/3 over the equal sign, and it becomes minus 81 and 2/3. And 3024 minus 81 and 2/3 will leave us with 2942 and 1/3. So then we need to get the r on its own. So we're going to divide across by 4 over 3. So 2942 and a third divided by 4 over 3. And that gives us 2206 and 3/4. So then we need to bring over the cubed part, and it becomes the cubed root. So we get the cubed root of 2206 and 3/4. And that's going to give us 13.0192 centimeters. So the radius is 13.0192 centimeters, and it rounds off to 13 centimeters, which is to the nearest centimeter, which is what we were asked for. Be careful with your rounding, because you'll lose a mark if you don't do this. So the radius of our sphere to the nearest centimeter is 13 centimeters. Now, along the way, we had mixed numbers. So we had 81 and 2/3. We had 2,942 and 1/3. We had 2,206 and 3/4, etc. We could have changed those into top-heavy or improper fractions as we were working through our sum. So for example, 81 and 2/3 to change into a top-heavy or improper fraction, you can put into the calculator 81 plus 2/3, or you could have done 3 multiplied by 81 plus 2. So it might be easier to work with as top-heavy or improper fractions. What you would not want to do is use decimals the whole way through, because you would be rounding off. And if you round off before the end of a sum, you'll have an error in your answer. So we'd only really want to use a decimal near the very end, so that when we round off, we get as close to the real answer as possible.